Okay, good morning, good afternoon, or good evening to my little mathlings. This is my first attempt at some sort of recorded tutorial. It's all about the unit circle. But to start with, I want to freshen up your memory on basic right angle trigonometry. Now, you'll remember if I have a right angle down here, and if I select an angle, like this one here, x, then this side is the opposite, this side is the adjacent, and the longest side is the hypotenuse. And we have defined since grade 9 the sine of that angle to be the length of the opposite side divided by the length of the hypotenuse. And we defined the cosine of the angle to be the adjacent side divided by hypotenuse, and the tan of the angle opposite divided by adjacent. I'm hoping you all remember that. So that was grade 9, possibly grade 10. Then we came into grade 11. No, we didn't. So that was grade 9. It came into grade 10. And suddenly things changed a bit. Instead of calling these sides opposite, adjacent, and hypotenuse, hide that, we call the angles and the sides by capital letters. So angles were capital letters, A, B, and C, and sides were small letters. So the side opposite this angle was called A. The side opposite this angle was called B, and the side opposite this angle was called C. So we came across slightly different definitions. So when we had this stuff, this only works for right angle triangles. Oh, go away. And so now, when we move that, and suddenly we don't have right angle triangles, we can use these new rules. Which I'm sure just at the front of your memory, and you've never ever forgotten these things at all. Well, what the purpose of this tutorial is to make you think maybe, we can expand on this. Let's not just be restricted to triangles. Instead, what I'm going to do is take you to something called the unit circle. Obviously, this is the circle. Why is it called a unit circle? Well, it's called a unit circle because if you look closely, the radius of this circle is 1. So 1 across here, 1 up here, etc., etc. A unit being another word for 1. Okay. Now, I'm going to look at a radius coming out from the center of the circle. I'm going to spin it around. Whee! I bet you wish you were here, but you probably enjoy doing that. Now this down here is the angle that's made between the radius and the x-axis. If I go around here, I say I'm making a positive angle. Now if I was to do this, very cheeky, I would say that angle here was a negative angle. Now here it just says 19.39. That's the way the software works, but we'd say that was a negative angle. So if I go around anti-clockwise, are called positive angles, and clockwise, then this angle up here is called a negative angle. Are you still with me? I hope so. Now, thinking about our definition of sine, cosine, and tan. This angle down here. Now, what would be the cosine of this angle? Cosine of this angle would be the adjacent side, this bit here, divided by the hypotenuse. let's think a bit more carefully then. Now, the adjacent side of this right angled triangle is actually equivalent to or equal to the x coordinate of this point up here. It's this point down here, isn't it? So that distance is equal to the x coordinate of this point A up here. So the adjacent is the x coordinate of A. Now, cosine is adjacent over hypotenuse. What's the hypotenuse? Well, the hypotenuse is the radius of this circle, and the radius of this circle is 1. So the cosine of this angle down here is equal to adjacent, which is the x coordinate, divided by 1. Divided by 1, well, we all know what that is. So I can now safely say that the cosine of this angle is equal to the x coordinate of this point, which is the same as this point here. Sorry. What about the sine? I hear you screaming at your computers. Right. The sine of this angle is what? It's equal to the opposite side divided by the hypotenuse. So what is the length of the opposite side? Well, the length of that is equal to the y coordinate of A. Now, if we forget about triangles now, well, not forget, just sort of put them to one side and redefine the whole idea of what a cosine and sine of an angle is. If I can say that within a unit circle, that's a circle with radius 1, any angle here, the cosine of that angle is equal to the x coordinate of this point, and the sine of this angle is equal to the y coordinate. Now, by using that definition, suddenly we don't have to think about sort of angles just being between 0 and 90, or just between 0 and 180. Now I can suddenly look at angles way over here, or even down here, or even over here. Oh, I can think of any angles at all. Now what does this thing say? What do I have here? Oh, no. Okay, so that's the first step then, to just rethink what the idea of sine and cosine are. Instead of thinking of it as being opposite over adjacent, and all that sort of stuff, instead to think of it as being connected to the coordinates of a point that's travelling round the unit circle. Right.